This is Lesson 4, Application Backup Concepts. This is the fourth lesson in this course. In this lesson, you'll learn about the requirements and needs for backing up enterprise applications, for backing up and restoring databases, and for using NetBackup Notify scripts to automate the protection of applications. This is the Understanding Application Needs topic. This slide describes the high-level concerns you need to consider when preparing for application backups. At a minimum, you should be asking, is this data going to be consistent for recovery, and does the protection of this data require any application state changes? And who's going to be initiating this backup? Will it be NetBackup, or will it be the application? And are there any restrictions when the backup runs? And what kind of automation will be in place? Will this be controlled by the NetBackup scheduler, or will there be another manual process involved, or will I be using another source of automation such as cron or the task manager? How will the application be put into or out of a backup state, and what sort of notification might be required? Backups can be initiated in NetBackup in one of three ways. The vast majority of backups in most environments are going to be created automatically, scheduled by NetBackup policies, and controlled by the frequency or calendar and start window settings in the NetBackup schedules. Policies can also be kicked off manually. That means that an authorized administrator or operator is choosing to run a policy from the master server out of its normal sequence. Now, most of the time it's done manually, like the name implied, although that could be automated by using scripting, by using cron or the task manager or a third-party job scheduler. Another option are user backups, which are really client-requested backups. This is the ability to create a user backup or a user archive schedule, which allows clients to request backups. User backups are always requested from the client. They cannot be initiated from the master server. Now, one of the things we'll talk about in this lesson is how some NetBackup agents make use of application schedules, and these application schedules are basically user backups. And again, maybe the better term here would be client-requested backups, where the application instructs the NetBackup client software to connect to the master server and to request a backup. This slide shows different types of NetBackup policy types. Other NetBackup training, such as the administration course, covers file system backups, catalog backups, virtualization backups like VMware in quite a bit of detail, but does not cover topics like database and application backups in so much detail. We'll be talking about these types of backups in this lesson, and we'll have a number of follow-on lessons after this one where we'll explore database and application backups in quite some detail. In many cases, when backing up a major enterprise application or database, you may have a choice of different methods and a choice of policy types to use. Here's an Oracle example. How will I protect this Oracle database? Well, the coolest way to do it is option 3, the NetBackup for Oracle Agent, where it's fully integrated and scheduled by NetBackup, and records of the backups are being tracked in the NetBackup catalog. This usually provides the best recovery point and the best performance, but maybe I don't have the Oracle Agent, or I haven't been able to convince my DBAs to work with me to get the Oracle Agent configured. Be an option to do a file-level backup, option 1, shut down the database, back it up with a standard or Windows policy, and then fire it back up again when you're done. Now, you can get a consistent backup that way, but I took the database offline to do it, so that's not going to be attractive in many cases. Maybe option 2, what they call the RMAN controlled backup, where a backup is created using RMAN to a specific path, and then I use a standard or Windows policy to back up that path. This is often referred to as a dump and sweep or a dump and scrape strategy. And I can get an effective backup that way. In fact, this is fairly commonly used. It has its limitations in that my backups are always point-in-time backups. If someone wants me to do a recovery, the best I can do is give them back what I backed up as of my last backup job, the last time we did a dump. I can't give them the kind of continuous up to the point of failure recovery that would be possible if I was backing up archived redo logs using the Oracle agent. Also, that recovery is going to be a multi-step process. With option 2, instead of recovering directly to Oracle, I'm just going to be able to restore whatever data was dumped, and then the DBAs are going to have to perform the recovery of the database. When we talk about backing up major applications and databases, we can separate the different backup types into some broad categories. The first one being enterprise applications that are BP-BICR-based backups. In other words, the data protection uses the standard NetBackup client process, BP-BICR, and it behaves a lot like file system backups. We configure this using NetBackup policies, using directives, and we restore data using the bar tool. It's not so different than a regular file system backup. By comparison, stream-based backups allow me to configure an agent in NetBackup to have an application or database stream data to NetBackup using application and sometimes automatic schedules. And so the schedule types are different than normal file system backups. And when it comes to the backup selections, instead of selecting objects by browsing or by directives, oftentimes these policies will initiate scripts, and the scripts really control the backup and the recovery. A third and more recent type of backup would be intelligent backups. Intelligent backups, which are currently available for Oracle and SQL Server, accomplish complete protection of the database using the database agent, but using an intelligent policy, which means I'm not getting into writing scripts or batch files to protect the data. I'm able to use a simple graphical interface to provide robust protection. Here is a more detailed comparison of the different backup types. We can see that the BP-BICR-based backups for enterprise applications use regular frequency or calendar-based schedules, and oftentimes will support user schedules as well, whereas the stream-based backups use these special application backups and automatic backups. The application backups are just a variant of user backups. They're a client-requested backup. The automatic schedules are a special method for allowing NetBackup to invoke this activity. Now, the intelligent policies will use regular frequency or calendar-based schedules, so they'll be more like the BP-BICR-based agents, the only difference being that they don't currently support client-requested backups. There are some features in NetBackup that work with specific application agents to provide for enhanced backup and/or recovery. Granular Restore Technology, or GRT, is supported with Exchange, SharePoint, and Active Directory, and that is the ability to do a single pass backup of an object, such as a Microsoft Exchange information store, and still be able to extract individual items with it. So in the example of Microsoft Exchange, backup the information store in a single pass. I have the whole DB, it's good for disaster recovery, but I can use GRT to extract individual mailboxes or even individual emails from it. Another type of feature we see in some application agents are blibs. These are block-level incremental backups, and these are extremely granular incremental backups. Unlike regular incrementals, which happen at the file level, blibs are much more granular than that. They happen at the file system block level. So we're usually talking about something between 1 and 8 kilobytes of data. So it's a very granular change detection and therefore a very high-performing incremental backup. We see this these days primarily in VMware backups, although they're also possible in Oracle backups. This is the Database Backup and Restore Concepts topic. A database is an organized collection of data, and it is usually made up of multiple different components, and those components may require different strategies for adequate protection. A lot of times, in order to ensure consistent protection of a database, we need to make sure we're protecting the actual data files themselves, and also the transaction logs, and also the metadata that exists in a control file or a control database. NetBackup agents allow you to configure complete and robust protection for databases, and NetBackup provides database agents for most major relational databases. We mentioned that databases are made up of different types of data, and different folk have different views of that data. The external or user view is what a user of the database sees, and a database view is usually just a slice of the database, not all the data that's there, and only the data, not any of the metadata or supporting structures. Compare that to a DBA, who is a more conceptual view of the database, where they see the data and the metadata, and they see it organized into tables and table spaces. But in many cases, they're used to thinking of the database in terms of logical structures, like table space. In order to accomplish complete protection of the database, we eventually have to get down to the physical level and back up the actual physical files that comprise the database. And again, the three broad categories that most relational databases have are the data files, the transaction or redo log files, and the database configuration data. This slide discusses different types of failures that can happen to databases, ranging from minor hiccups like a process accessing the database incorrectly to more serious issues like network disconnects, host aborts, corruption of data, disk failure. Now, relational databases are robust applications with some amount of built-in resiliency. So for some of these minor issues, like inaccurate access to the database or an unexpected reboot, the database is usually able to restore itself to a consistent state by using its transaction or redo logs. In the case of device failure, many times layers of protection are used, such as storage redundancy or snapshots. So where NetBackup really gets involved is where we have more serious problems with the database, where we have multiple device failures, where we have the complete loss of a host, where we have serious corruption of data. That's where oftentimes we're looking to NetBackup to be able to recover data. There are some decisions to make about my backup strategy before I begin the process of actually configuring NetBackup. Am I going to do physical or logical data backups? And am I going to be able to do online backups, or may I have to do offline backups? Will I be protecting the entire database, or will I only be protecting parts of it? Or maybe I'm protecting the whole thing, but different parts of it need to be backed up with different frequency because it has a differing change rate. Will I be looking to do full backups only, or will I be able to make use of incremental backups? And what will my eventual storage destination be? Will it be tape, or will it be disk? Will it be deduplicating disk? How am I providing for multiple copies? Am I using duplication or replication? These are all things that get planned out ahead of time before I actually start pushing any buttons. Most NetBackup database agents fall under the category of streaming backup, which means that we protect them using application schedules. Application schedules are a special type of user backup or client-requested backup where they're initiated from the database server itself. And so when you use an application schedule, the database attempts to initiate a backup by using a backup script, which is either kicked off by a NetBackup policy or run manually by the DBA. Now this causes the client to connect to the NetBackup master server and look for an application schedule with an open start window. If there's an application schedule open in the correct policy type and the start window is open, then the master server says, yes, that's okay, send me your data, and the database streams data to NetBackup when resources are available. Always think of these application schedules as user backups. Any rules in NetBackup that apply to user schedules apply to application schedules as well. So for example, in NetBackup, you can't use an exclude list with user backups. You can't use an exclude list with application schedules as well. With streaming backups, the application schedules are what really allow me to protect my data. And so what are these automatic schedules? The automatic schedules are basically just an alarm clock. They're a way for the NetBackup master server to have a schedule that runs, using the NetBackup scheduler. And when that schedule runs, it reaches out to the client system and says, hey, go back yourself up now. And that's it. That's really the sole purpose of the automatic schedule. And the reason why we have this is because, remember, these application schedules that are really protecting the data are user backups. They're client requested. and they cannot be invoked from the master server. They have to originate from the client. And so the automatic schedule is just a way to use the NetBackup scheduler to instruct the client to back itself up, so that it can be protected at regular intervals and managed pretty much the same way as all my other backups. So any policy that has an automatic schedule will always have an application schedule too. So the first thing that happens, the automatic schedule runs, reaches out to the client and says it's time for you to go back yourself up. The database then runs a script. The script sets the backup parameters, causes it to reach out to the NetBackup master server and request permission to be backed up. If the start window is open, and presumably it is, presumably we have the same start window for both of these schedules, then the master server says, yes, that's good, back yourself up, and the database agent streams the data to NetBackup using the settings in the application schedule. This is the Customizing Generic Application Backups topic. We always recommend using NetBackup agents to protect applications and databases when those agents are available. Now, if there is a particular application we need to protect and there isn't an agent available, that's when we start talking about how to back up generic applications using NetBackup. And so there's a little bit more manual method involved here. And it begins with understanding your application's recovery needs. Where is the data stored, and what's the critical data that needs to be protected? What about metadata? Is there some kind of control information that needs to be protected? And how am I going to go to recover this? Is there a particular restore procedure I'm going to need to do? I can use file system-based policies to back up specific data locations using regular calendar or frequency-based schedules. Or I can use user schedules and make it more of a client-requested operation. And again, those user schedules could be invoked by scripting or other automation on the client. I can also make use of the NetBackup Notify scripts to do any necessary pre-processing or post-processing to make sure the backup is successful. So that if I need to quiesce the application or put it into a backup mode before a backup can be successful, the Notify scripts will really help me out with that. The NetBackup Notify scripts are event-triggered scripts that run at certain points during backup and restore operations. Basically, each script is an opportunity to add some logic, some kind of activity that's going to take place during the backup process. There are scripts that can run on the master server, the media server, and on the clients. And generally speaking, the scripts that are located on the backup servers are used for notification, to send out an email, to update a spreadsheet or a web page, or to send out some other sort of notification that a backup has been successful or unsuccessful. Now, a lot of times these days we have more robust tools like Ops Center that we can use for alerts and notification, but the functionality still exists in NetBackup. Now, when we talk about client scripts, usually client scripts are used for pre-processing and post-processing of backup jobs. So unlike notification, they're usually used to do things, to quiesce an app, maybe shut it down entirely, maybe put it in backup mode, maybe take a snapshot of some data, and then the backup job can run. And then when the backup is successful, a post-processing script can return the application to normal mode. This is a good graphical example of how Notify scripts play into the backup process. And these are not all of the Notify scripts here, just the major ones that we've identified on this slide. And so we see that at the start of a backup session, session start Notify script runs on the master server. And then for every job that's part of that session, the backup Notify script runs on the media server at the end of the job. The backup exit notify runs on the master server at the end of every job. And then at the end of the entire session, when all the jobs are in the done state, the session notify script is called on the master server. These scripts on the master server and the media server are present by default. They're always running. By default, they don't really do anything. They either do nothing or they create a simple output file. I can add logic to these scripts to have them do things like, for example, to email out a summary of backup activity using the session notify script, for example. Now, the client scripts are not active by default, but if I want to, I can have these scripts running on the client, BP start notify will run before the backup job. BP end notify will run after the backup job. And again, they will usually do some sort of pre-processing or post-processing to help me back up a major application in a consistent state. I have to be careful with client-side scripts that they run successfully, because if the BP start notify script fails, NetBackup will fail the job. The assumption being that if this pre-processing didn't take place, then the backup is not going to be consistent and usable, and we better raise a red flag about that. So that's why the scripts are not running on clients by default, and that's why if I use client notify scripts, I want to make sure I test them thoroughly. I really want these scripts to be bulletproof. I don't want failed jobs because of silly scripting errors. In order for the NetBackup notify scripts to run, they must be present in a NetBackup bin directory. As we mentioned before, for NetBackup servers, these scripts, or at least most of these scripts, are already present in the bin. Some of the scripts, in particular the client scripts, are not. They're located in the goodies directory. So if I want those scripts to run, I need to copy them from the goodies directory to the bin, edit them to add whatever logic I want to add, and then save them and make sure that the extension on the script allows it to be executed. So for example, in Windows it should be a .bat or a .cmd. As the slide recommends, test these scripts robustly, both outside of and inside of NetBackup. And if you want to have one of these scripts call another script, that's perfectly fine. And that would allow you to do scripting in different languages. You know, the NetBackup scripts are regular batch files or shell scripts. If I wanted to do some Perl scripting, I could just have one of these NetBackup scripts call a Perl script. And then the other nice thing about that is I'd be maintaining my scripts outside of NetBackup. So if anything ever happened that the scripts on the NetBackup server were overwritten, hopefully I've got them tucked away somewhere else. This slide here identifies some particularly useful scripts for application control. So for example, backup exit notify runs on the master server every time a backup job completes. BP start notify runs on the client just before a backup. BP end notify runs just after the backup. Most of the time, BP start and BP end are what we use for application control, although you could use a script on a NetBackup server if you wanted to do it that way. Note specifically with BP start notify, it must return an exit code of 0 within the timeout, which by default is 5 minutes. If it does not return an exit code of 0, NetBackup fails the job. You can adjust that timeout and make it longer if you need to in the host properties, but it's got to eventually return success. Also note that for the client-side scripts, you can append a policy name and even a schedule name, so the script only runs, for example, for certain backup policies, and there certainly are many times when you might want to do that, where you might want to have two policies that backs up a client, one that backs up the operating system, and a separate one that backs up the application, and you only want a script to execute and put the application into a quiesced mode when a particular policy is running. There's a lot of utility to that. Also note, when you're working with these scripts, that they receive environment variables from NetBackup. So a lot of these scripts know details. Backup exit notify knows which policy just ran and which schedule just ran and what the exit code was, if it was successful or not. And that's all information that you can use in your scripting. Here are some best practices for using notify scripts for application control. Always use that option to identify a policy name on the notify scripts to make sure they're not called by mistake. Use application startup and shutdown scripts if possible to control the application in the notify scripts. Test them from the command line outside of NetBackup to isolate any possible scripting errors, and again make sure that they're able to run successfully in the time allotted. The default timeout is 5 minutes, and that's adjustable. Here's an example of the client notify script timeouts. BP start notify, BP end notify both have a 5-minute timeout by default that can be increased. Note that backup start notify can cause a failed job. It will cause a failed job if it doesn't return success within 5 minutes. BP end notify can't really cause a failed job because the job will have completed before the notify script is called. However, if the script does not run successfully, any error code it returns will be captured in the NetBackup logs. Here's a sample bpstartnotify.bat file on Windows. You see that these scripts are heavily commented, so there's a lot of information here about what environment variables this script receives from NetBackup and what the script does, if it does much of anything. And sometimes there's even some sample suggestions for what you can do with the script in the comments. Here's an example of the same script, bpstartnotify on Unix. Basically does the same thing, but there are some subtle platform-specific differences. For example, you'll notice this receives a different number of parameters than the Windows version of the script did. Here's an example of using notify scripts. In this case, we'll use a notify script to integrate NetBackup and Oracle. And so using the bpstartnotify script, we have commands to stop an Oracle database. After that script returns success, the policy runs and protects the database, and then the bpn notify fires the database back up again. Now this is just to illustrate, because Oracle is a common database, there are of course much more preferable methods for protecting Oracle than to take the database online. I really should be using the NetBackup for Oracle Agent, but this is just to give you an idea of the kinds of things that are possible using notify scripts. In this lesson, we kind of gave a high-level overview, discussed the basics of database backups and application backups. For the next few lessons in this course, we're going to take a specific and detailed look at some of the most popular NetBackup agents. Oracle, Microsoft SQL Server, Microsoft SharePoint, and Microsoft Exchange we're all going to explore in specific lessons. In this lesson, you learned about the requirements and needs for backing up enterprise applications and databases, and you learned how to use the NetBackup notify scripts to automate the protection of generic applications. This concludes Lesson 4.